Yes, good morning everyone. And we discussed regarding the volume strength yesterday. Do you have any doubts in that volume strength? No, just I want to do hydrogen only again. Good morning, good morning. Yes, I am going to do same hydrogen only. Is voice everything is clear? Voice, video, everything is clear? Yes. So yesterday I given one formula for calculation of volume strength. What is that one? 3% H2O2 is equal to 10 volume, and which is going to be equal to 0.89 molar, which is equal to 1.78 normal. So this is what the formula you can able to use for any particular calculation. That's what I said yesterday. And now when we are going to see the questions which are going to be giving, sometimes they are asking normality and volume strength. So what calculations you can able to use? Normality, which is going to be equal to the volume strength by 5.6 molarity, volume strength by 11.2. If they are going to be giving you the percentage, weight by volume percentage, which is going to be volume strength by 3.3. Volume strength by 3.3. This is what we are going to have. So the same all these things can be done by this particular one. You are able to use this one only for any particular calculation. If at all they are going to be asking directly that percent weight by volume. So these two we can able to get it from this one. But this one we are going to remember this one again, one more formula, volume strength by 3.3. So this is what we are going to have. And if at all they are asking volume of oxygen liberated, volume of oxygen liberated or released, which is going to be equal to the volume strength of H2O2 and volume of H2O2 what you have taken. So if they are asking how much ml O2 is released, then we can able to take how much volume of H2O2 and it is multiplied with volume strength, then we can able to calculate the volume of oxygen liberated. So these are all the things we can able to use for the calculation of your volume strength based questions. Whatever the volume strength based questions if you are going to get, that all the questions we can able to be answering based on this one. Chapter completed ma, just volume strength just I am going to explaining. So yesterday I said no, already I solved in the where we are having the numericals in your some basic concept chemistry already Srinath sir and Ravindra sir might completed. Just if at all any problem is there, just I want to clarify the doubts. That's it today. Otherwise hydrogen is going to be already completed. So any question, doubts you are having, you can ask me. That's why I am not muted all. If at all you are having the doubts, you can able to ask me. Any doubts are there? You can unmute and you can ask me. Otherwise, I will explain from our material. Biomolecules today it's not uploaded, just we are going to be uploading now. After my class it is going to be uploaded. Revision whole chapter. Material itself, sir. Sir, I am unable to unmute. Explain from material. Okay, so the material questions which are there in, based on the volume strength, I am going to be explaining. So this is a 101 question, not 101, 100 also is there only. The volume strength of one normal solution of H2O2. They are asking the volume strength of one normal solution of H2O2. 100th question in the material. What is the volume strength of one normal H2O2? So you can use this formula. So what is the normality? 1.78 normal is equal to 10 volume strength. So it is going to be 1.78 normal is going to be 10 volume strength. They are asking for one normal, what is the volume strength? So it is going to be equal to 1 into 10 by 1.78. So which is going to be 5.6. Which is going to be 5.6. So that's what the calculation, 5.6 V will be the answer for this question. If at all directly you can able to remember this formula, normality is equal to volume strength by 5.6. One normality they given 1 into 5.6 is going to be 5.6 volume strength. Understand? Volume strength of one normal H2O2. This is the question. So when they are going to be asking like this, you can use this formula. You can use directly this formula. No issue. Anything you can able to use it. Volume strength is equal to 5.6 into normality. So 5.6 into 1 normal they are asking, 5.6 into 1 is going to be 5.6. So this is the 100th question. And next they are asking 101 question, 3.4 gram of H2O2 decomposes, the weight of oxygen liberated from it is. So 101 question they are going to be asking like the decomposition reaction. So what is the decomposition reaction we are going to have? H2O2 gives rise to H2O plus O2. If at all 2H2O, 2H2O. So that means 2 moles of H2O2 is going to give you the 1 mole of O2. They are asking like 3.4 gram. So based on this one, 2 into 34 grams is going to give 32 grams of oxygen. 3.4 grams is going to give how many grams of oxygen? 2 into 34 grams of H2O2 is going to give 32 grams of oxygen. 3.4 grams of H2O2 is going to give how much? So it is going to be equal to 3.4 into 32 by 2 into 34. So this one is going to be 10 times, this is going to be 16. So which is equal to 1.6 gram. 1.6 gram. So this one will be the answer. So this is the 2 moles of H2O2 stoichiometric equation. You are supposed to write it. 2 moles of hydrogen peroxide is going to be giving you 2 moles of water and 1 mole of oxygen. So 2 moles means 2 into 34 grams. The molecular weight of H2O2 is going to be 34. So 2 into 34 is liberating 32 grams of oxygen. So 3.4 grams is liberating how many moles of oxygen or how many grams of oxygen. So just here doing the simplification, we are going to get 1.6 gram. So that will be the volume strength question 101. And next 102 is going to be theoretical question only. In which of the following reactions H2O2 acts as reducing agent? So there we are supposed to remember. So that equations what I given yesterday. And the next one 103 is also conceptual only. 104. The volume of Perhydral which on decomposition gives 1.5 liter of oxygen gas. I am going to discuss again the question 104. So in 104 question what they are asking, the volume of Perhydral which on decomposition gives 1.5 liter of oxygen gas at STP is. What is Perhydral? Perhydral, I already said it's a commercial hydrogen peroxide which is going to be sold out 100 volume strength or 30%. 30% H2O2 is going to be called as perhydral. So this 30% H2O2 is going to have 100 volume strength. What is the meaning of 100 volume strength? I said the volume strength when we are going to take 1 ml of H2O2, if I am taking, it is going to be liberating 100 ml of oxygen, or 1 liter H2O2 if I am taking, it is going to be liberating 100 liters of oxygen. So what is the meaning of this V? How many ml of we are taking, that many 100 times oxygen I am going to get. That's what I given here. Volume of oxygen is equal to volume of H2O2 into volume strength. Say what it is going to be, 1 ml of H2O2 if I am taking, 1 into volume strength is 100. So 100 times of oxygen gas is going to be liberated. If at all I am going to get 100, I am going to get volume. So 100 into 100, 10,000 ml is going to be obtaining the volume of oxygen gas. So this is what we are going to have, the oxygen gas liberation. So this 100 is indicating 100 times of its volume oxygen liberation. That's what we are going to get it. Understand? Now when we are going to take they are asking like the question, 105 liters of oxygen gas at STP, the volume of perhydral which on decomposition gives 1.5 liter. According to this one, 1 liter of H2O2 is liberating 100 liters. They are saying like 1.5 liter only. So 100 liters are going to be getting by 1 liter of H2O2 decomposition. So if at all I want to get 1.5 liter of oxygen, how many liters of H2O2 I am supposed to take? So this is nothing but 1.5 into 1 by 100. So this is what we are going to get. So this is going to be around 0.015 liters. So which is equal to 15 ml. 15 ml of oxygen. So 1.5 by 100 is nothing but 0.015. So it is going to be equal to 15 ml. So that's why the answer is going to be 15 ml. 104 once again. 104. 104, the perhydral is going to be 100 volume. Perhydral is nothing but 30% H2O2 is going to be called as perhydral. So this 30% H2O2 is equal to 100 volume strength according to that formula what I given. 3% is 10 volume, 30% is going to be 100 volume. So that's a 30%, 100 volume strength H2O2. What the meaning of this volume strength? Whenever you are taking 1 ml of H2O2 of 100 volume strength, it is going to be liberating 100 ml of oxygen. 100 times of this particular volume strength is nothing but the volume of oxygen liberated. And now 1 liter of H2O2 is taken, is liberating 100 liters of oxygen. But what the question they are asking? 1.5 liters of oxygen is going to be obtained. Then what will be the volume of H2O2 I have to take? So 100 liters of oxygen is liberated by 1 liter of 100 volume H2O2. So 1.5 liter of oxygen is liberated by how much volume of 100 volume H2O2? That is the equation. So 1.5 into 1 by 100. So which is nothing but 0.015. So which is going to be equal to 15 ml. It is going to be liters. 15 ml will be the answer. Okay, so that is 104th question. And next one, 105 question. 105. So what is the 105 question? They are given weight of H2O2 present in 560 ml of 20 volume H2O2 solution approximately. So they are asking the weight of H2O2 present. How to get the weight of H2O2? So normally the molecular weight of H2O2 is nothing but 34 grams. Normally it is going to be 34 grams. So they are given the volume strength and they are asking what will be the weight of that particular substance. So they are asking 20 volume H2O2 solution, 560 ml. 105th question, they are asking weight of H2O2 in 560 ml, 20 volume strength H2O2. So this is what the thing they are asking. So 20 volume strength H2O2, if you are taking, how much we are going to get, and they are going to be giving you H2O2 in 560 ml. So now when we are going to be calculating, so based on percent W by V is equal to volume strength divided by 3.3. So this is what we given the weight we are going to get in particular one. So it is for 100 ml. So which is going to be equal to volume strength is 20, 20 by 3.3. So this is nothing but around 6 grams we are going to get. Approximately I am writing it 6 grams in 100 ml. So they are asking in 560 ml. Understand for everyone? So percent W by V, already we calculated the formula given, volume strength by 3.3. So now 3.3 grams, volume strength are given 20 volume. So 20 volume by 3.3, it is nothing but 6 grams present in 100 ml. So 560 ml is going to be consisting of how much? If 100 ml is going to be consisting of 6 grams, 560 ml is going to be consisting of how much? So it is nothing but 560 into 6 by 100. So approximately you are going to get 34. Approximately you are going to get 34 grams. If you are going to divide them, so 6 into 5.6. So that's why it is going to be around 34 grams you are going to get it. So that the options we are having 30, 69, 34, 32, 33.4. So you can able to get the 34 grams. Understand for everyone? Weight of H2O2 present in 560 ml of 20 volume strength H2O2 they are asking. According to the formula, so this is the formula, you can take it, otherwise what you are having already 3% is equal to 10 volume. So 20 volume is equal to 6%. Isn't it? The calculation formula what we given, so 10 volume strength is equal to 3%. If it is 20 volume strength, 6%. So that means 6 grams is going to be present in 100 ml. So if 560 ml if I is taken, how many grams it is going to be present? So 560 into 6 by 100, it is going to be giving you 34 grams. Understand? So this is how we are able to make meaning of volume strength. Meaning of volume strength I said no. How much volume of oxygen is liberated by a given H2O2. The H2O2 concentration is going to be explained in terms of volume strength. Volume strength is nothing but how much volume of oxygen liberated by that particular ml of H2O2. 1 ml of H2O2, if it is liberating 10 ml of oxygen, we are going to say 10 volume strength. If it is liberating 100 ml of oxygen gas, then it is going to be called as the 100 volume strength. 30 volume strength means 30 ml of oxygen gas is going to be liberated, then it is going to be called as 30 volume strength. That is the meaning of volume strength. Sir, we can guess the answer by calculating its molecular weight. Yeah, you can guess the answer, but I have to explain that correct process. Sir, states of matter, nothing online will be provided. States of matter already offline completed, what you want online. If they given 20 volume and 560 ml, yeah, that's why you did, no? I have to explain the volume strength questions. Still more models are there, just I have to. So 107th question. 107th question if you're taking. In a reaction, excess of H2O2 is added to 0.1 mole of acidified KMnO4 solution, then the STP volume of O2 liberated. So for this one, we are supposed to remember what the equation we are having with the permanganate, and also when we are going to be taking hydrogen peroxide, what is the reaction. So what is the reaction we are going to have? MnO4 minus plus 6H plus 5 moles of H2O2 is going to be liberating Mn2 plus 8 moles of H2O and 5 moles of oxygen. This is what the equation I given yesterday. When we are going to take excess of H2O2, they are saying it, but when you are taking 2 moles of permanganate, I am going to get 5 moles of oxygen. But what they are asking, 0.1 mole of acidified KMnO4 solution, then the STP volume of liberated is. So according to this equation, it's not a limiting reagent because they are taken excess. What is the limiting reagent? The permanganate is only going to be the limiting reagent. 2 moles of permanganate is going to be liberating 5 moles of oxygen. Now 0.1 mole permanganate will liberate how many moles of oxygen? So here it is going to be 0.5. 0.1 into 5 by 2. So it is going to be 0.25 mole. So 0.25 mole is nothing but into 22.4. 1 mole is 22.4, 0.24 is 5.6 liters. Understand for everyone? So they are asking the volume of oxygen liberated by the 0.1 mole of permanganate. When they are going to be asking such questions, we are supposed to know what will be the equation for that particular one. So now permanganate, when you are going to take the peroxide, we are going to get 5 moles of oxygen. So that's what we wrote. 2 moles of permanganate is going to be liberating 5 moles of oxygen. So 0.1 mole is going to be liberating how many moles of oxygen? So that we have calculated 0.25 mole. So 0.25 mole of oxygen is going to be occupying at STP how much volume? Normally 1 mole will occupy 22.4 liters. So 1/4 mole is going to be occupying 5.6 liters. So that's why 5.6 liters of oxygen gas is going to be liberated by 0.1 mole of potassium permanganate. That's what you can able to understand from this one. And next 108th question. So 108th question, what they are going to be asking us? 25 ml of H2O2 solution were added to excess of acidified potassium iodide solution. The iodine so liberated required 20 ml of 0.1 normal Na2H2O3 solution. Calculate the strength in terms of normality and percentage. That's what the question they are asking. That is a 108th question. Volume or confusion? Which one? Yeah, 108 I am explaining now. So this one I already explained, no? So just I am going for now 108th question. So 108th question, they are given 25 ml of H2O2 solution were added to excess of acidified Ka solution. So for this, what is required? We are supposed to know what is the reaction between H2O2 and potassium iodide. So actually this one is going to be quantification. H2O2 plus 2 Ki gives rise to 2 KOH. When you are going to take H2O2, it is going to be liberating the iodine. So that is a quantification I2. So I2 liberation. Based on the I2, we can estimate the amount of H2O2 what is going to be liberated. So the H2O2 quantitative estimation can be done by using this method. So that is what we are having the application. So potassium iodide is going to be useful for the quantitative estimation of H2O2. Why? Because how much amount of iodine is liberated, that can be estimated by using Na2S2O3, so that we can able to estimate indirectly the H2O2 how much is going to be liberated. So now this is the equation we are going to have. H2O2 plus 2Ki is gives rise to 2KOH plus I2. And the next what they are given? So liberated required, the iodine so liberated required 20 ml of 0.1 normal Na2S2O3 solution. So again we required what is the equation between Na2S2O3 and iodine. When we are going to take this one, 2 moles of Na2S2O3 plus 1 mole of iodine is going to give Na2S4O6 plus 2 moles of NaI. So this is what the equation we are going to have between the sodium thiosulfate is going to be get converted to tetrathionate and 2 NaI. So that is what we are going to have. When we are going to take hydrogen peroxide reacting with potassium iodide, it is going to be liberating the iodine gas. That iodine is going to be reacting with Na2S2O3 and we are going to get Na2S4O6. Now, based on these two equations, what we can able to write is the milli equivalents. Always we are going to take the reaction whenever is going to be taking place, their milli equivalents is going to be equal. So the number of, in the terms of equivalents only, the reaction is going to be taking place. So what are the content required for us? H2O2 and I2 and Na2S2O3. These three we are supposed to link up. So now we can able to write it here. Milli equivalents of H2O2 is equal to milli equivalents of I2. Isn't it? This is going to be milli equivalents of Na2S2O3. Can we write like this? Based on the equivalents only, the reaction is going to be taking place. That's why the number of milli equivalents of H2O2 should be equal to the number of milli equivalents of I2. And the number of milli equivalents of I2 should be equal to number of milli equivalents of Na2S2O3. So based on these two equations, what you can able to write? Milli equivalents of H2O2 is equal to milli equivalents of Na2S2O3. That's what the equation they are going to be asking us. That's why you are supposed to calculate by taking the milli equivalents of H2O2 and milli equivalents of Na2S2O3. How to get the milli equivalents of H2O2? So milli equivalents of H2O2 is nothing but weight by equivalent weight into 1000. Isn't it? Weight of H2O2 we don't know. W. Equivalent weight. So what is the molecular weight of H2O2? Is going to be 34. And its N factor is 2. So that's why the equivalent weight is equal to 34 by 2 into 1000. Why? Because milli equivalents. If you are calculating equivalents, 1000 not required. But we are calculating milli equivalent. That's why into 1000. Which is going to be equal to milli equivalents of iodine. They are not given in data. That's why we are not going to be considering this one. We are equating that one into milli equivalents of Na2S2O3. We are going to be equating to milli equivalents of Na2S2O3. So for this, what the data they given? So liberated required 20 ml of 0.1 normal Na2S2O3 solution. So number of equivalents we are able to get it by multiplying the volume in ml into its normality. What is the ml they given? 20 ml they given. So for 20 ml when they are going to be taking into 0.1 normal. Understand? This is the one basic for this question. So what we are doing now, when we are going to be taking, so that is moles, not milli equivalents. Equivalents when you are taking, we are not going to be considering these all the things. So that is not going to be 2 times. It is going to be moles it is. We are taking equivalents. That's why we are not going to be considering the stoichiometric coefficients. Okay. So now it is going to be milli equivalents of H2O2 is equal to milli equivalents of I2. Milli equivalents of I2 is equal to milli equivalents of sodium thiosulfate or hypo. We are going to be, now we are equating milli equivalents of H2O2 and the milli equivalents of Na2S2O3 based on the data what they given. So that's why weight by 34 by 2 into 1000 is equal to 20 into 0.1. So now we can able to calculate the weight of your hydrogen peroxide. So weight of hydrogen peroxide is equal to how much it is. If you are going to be calculating this 2, this 20 will be gone, and when we are going to get the weight is equal to 0.034 grams, we are going to get 0.034. But how much ml they taken? 25 ml they taken. So it is going to be present in 25 ml. It is going to be present in 25 ml. So now the normality we are supposed to calculate if 0.034 grams of H2O2 is going to be present in. Why have to do like this? How we come to know this? How we come to know this means this is the equation we are supposed to know it. Actually it is going to be explained in your redox reactions already. Just we are correlating here in hydrogen peroxide. So there you are supposed to learn as they given in this material question, that's I am explaining. These things you are supposed to know it from your some basic concept of chemistry and redox reactions only. So now the normality of H2O2. What is the formula of normality? Weight by equivalent weight into 1000 by the volume in ml. So weight, how much you got? 0.034. And the equivalent weight is 34 by 2, 17 into 1000 by 25 ml. Why? Because they given 25 ml here. Understand? So now this is going to be equal to, the simplification is going to be giving you the normality 0.448. Sorry, 0.08. I already calculated, that's why I am writing it here. So 0.08 normal, you are going to get that normality of hydrogen peroxide. Now they are going to be asking about the percentage also. So they are going to be asking percentage strength. So what is the percentage formula we given? So percentage W by V is equal to the volume strength by the 3.3. So that formula you can able to use, or directly you can able to use the normality. 1.78 normal is equal to 3%. So 0.08 normal is equal to how much percentage? Either of the way you can able to do it. So no issue. That percentage calculation, percent W by V is equal to volume strength divided by 3.3. So for 0.08 normal, volume strength. So the normality when you are taking 5.6, I said no, 5.6 into 0.08, which is going to be equal to 0.448. 0.08 into 5.6 divided by 3.3. So the 0.08 normal for this one. And now 0.08 into 5.6 is nothing but the volume strength when they are given the normality by 3.3. If you are going to do this one, you are going to get 0.136 percentage. 0.136 percentage. That's what we are having. They are asking the normality and the percentage both. The normality you are going to calculate by taking the equivalents, milli equivalents of H2O2 is equal to milli equivalents of Na2S2O3. And then we are going to be calculating the weight of H2O2 present in the given solution, that we got like 0.034 gram. But it is going to be present in only 25 ml as the data they given. Now the normality of H2O2 when you are going to be calculating, it is going to be 0.034 by 17 into 1000 by 25. We got the normality. So the normality is given. The volume strength is going to be calculated like volume strength is equal to normality into 5.6 and by 3.3, standard formula what I given earlier. Now we are calculating, you are going to get the 0.136 percentage. Understand? So this is what we are going to have the questions. And if any other questions you are having the doubt, you can ask me through personal WhatsApp. So these are the volume strength questions you are having. Okay, one more they given. So that is same thing like this one only. So acidified dichromate only, it is going to be permanganate. So you are able to get the milli equivalents of permanganate is equal to milli equivalents of H2O2. Based on that one, the next question. So same like what we calculated now, like that only it is going to be If at all any more doubts are there based on volume strength or any other questions, just you can able to ask me on WhatsApp number already we given. And tomorrow's exam, it is going to be conducted already. It is volume or the hydrogen up to this volume strength, and biomolecules are going to upload today the proteins next part and up to proteins only in my track. In my track, I am going to give the questions from biomolecules more and hydrogen is going to be less. That's why concentrate more on biomolecules and calculations and all, you can able to see the hydrogen. So you are supposed to be concentrate on the reading. So whatever we are going to be teaching here, just you can able to read on the same day. After remaining, the time is there, then you can able to go for lagging. So don't skip the daily schedule what you are going to uploading here. Those things are as it is should be completed. Then only you can go for the next one. Understand? Okay. Any more doubts you are having, just you can able to ask me. That 109 question only. Okay. 109 question. So 109, what they are saying, 20 ml of H2O2 after acidification with dilute H2SO4 require 30 ml of N/2 KMNO4. So for complete oxidation, calculate the percentage of H2O2 in gram per liter they are asking. So now, according to this equation, what you can able to say, the milli equivalence of MnO4 minus milli equivalence of MnO4 minus is equal to milli equivalence of H2O2, which is equal to milli equivalence of oxygen. That's what we are having from the equation. So what we are having now, milli equivalence of permanganate is equal to milli equivalence of the H2O2 and the milli equivalence of oxygen. Now, what are the things we are supposed to take? They are going to be asking about the hydrogen peroxide and this one. So that's why I will be considering these two. Milli equivalence of MnO4 minus is equal to milli equivalence of H2O2. So what is the milli equivalence of manganate? They given N/2 they are given and they taken 30 ml. So that's why 1/2 into 30 will be the milli equivalence of permanganate. And the milli equivalence of hydrogen peroxide, again the same thing, we are supposed to do it weight by 34/2 into 1000. So this is the milli equivalence of hydrogen peroxide. From this we are able to get weight of H2O2. So weight of H2O2 we are going to be obtaining from this one. So this is how much it is going to be, 0.255 gram. So we are going to be calculate this one simplification. We are going to be obtaining 0.255 gram. Weight of H2O2 present in that particular one is going to be 0.255. But how much you have taken? 20 ml we have taken. So that means it is going to be present in 20 ml. 20 ml of solution is going to be consisting of 0.255 grams. Now the normality is equal to weight, how much you got? 0.255 and the equivalent weight is 17 into 1000 by 20. So if you are going to simplify this one, you are going to get 0.75 normal. So they are asking about the strength in gram per liter. So this is the normality. When we are going to have the normality strength in gram per liter, how we are going to get it? If you are going to be multiplying your normality into its equivalent weight. If it is going to be multiplied into equivalent weight. So N into equivalent weight is going to be giving gram per liter. So now the normality is going to be 0.75. Equivalent weight of hydrogen peroxide is 17. If you are going to be multiplying, this one is going to give 12.75 gram per liter. So this is 109th question. Okay. So this is how the permanganate equivalence is equal to H2O2. That's what we will be knowing it. And now this permanganate equivalents are equal to H2O2. From this we are going to calculate the weight of H2O2. So that is nothing but 0.255 gram per 20 ml. Now we are going to calculate the normality. How we are going to be calculating? Same formula, weight by equivalent weight into 1000 by volume. We are going to get 0.75 normal. When they are going to be asking gram per liter, strength they are going to be asking in gram per liter. So that gram per liter strength, when you are going to be calculating normality into equivalent weight, is going to give directly gram per liter. So if you are taking gram per 100 ml, you are supposed to give the different one. Otherwise, it is going to be normality into equivalent weight. So that is going to be equal to 12.75 gram per liter. Okay. So this is the volume strength when we are going to have the calculations. And if any more doubts you are having, you can able to ask me through WhatsApp so that we will send the solution. Okay. Thank you everyone. So how to calculate normality? Normality calculations already done now. Normality is equal to weight by equivalent weight into 1000 by volume in ml. So that is the formula for normality. Biomolecules class, it will be uploaded. So now we are going to upload the same. Yes, every video is going to be uploaded. So this video also will be uploaded. Okay, Madan. So do well tomorrow exam.